Alex Seifert is a senior research scientist with the Conservation Biology Institute. She works a lot in social, ecological drivers of landscape change, has done a lot of really, really cool work in Southern California and has been expanding northward, as are some species currently. And she's going to talk about housing patterns, wildfire, and community vulnerability, historical perspectives, and future possibilities. Great. Thanks.
Okay, so
You just saw the thing? Forward, backward, that's your pointer.
pointer.
Yeah, exactly. And if you hit that button there, that's nuclear Armageddon. Do not hit that one.
Okay, good to know. And you need to oh, okay, like this. Okay. I put et al. Because what I'm going to be talking about has been done along with me, a number of other colleagues, and I have a list of them at the end of the talk. So this is not just my work. I have shortened the title a little bit because the one I provided was quite long. And I'm going to be talking about housing patterns and wildfire and how they both relate to community vulnerability to wildfire. And I'll start out by giving some historical perspectives and then conclude with some projections for the future of structure loss and fire and some possibilities. But somewhere between the past and the future, of course, is the present moment. And the present moment right now is we're sitting to the right of that arrow. We're less than a year away from the most catastrophic wildfires in California history in terms of human impacts. And so the present moment can be characterized by having some fresh memories of some difficult times. But the present moment is also a time to reflect and to ask the question, what happened? And is this going to happen again? Well, the wise man Confucius has said, study the past if you would understand the future. So I'm going to take a step back to the past and go to the 1940s in California. The 1940s was a time of big transition. Some industry that used to be big, like big lumber, was starting to phase out. New industries were coming in. World War II was ending, so it was a time of economic growth and prosperity. It's also the time of the automobile and the beginning of the freeway system in California. So that by the time we got to the 1950s, Roger Kennedy from the Park Service has said, tens of millions of people broke away from their fire-tamed places and moved to the forest grasslands and chaparral-covered slopes where fire often goes wild. So there was a trend to start developing outward into a sprawling type pattern. And why? Well, one was that there was the automobile, so it provided a means to do that. But there were also easy zoning laws, so there were financial incentives to move out from the city, and demographics were changing. Family size was getting smaller, but population was getting larger. And of course, as Alex Krieger had put it, the majority of sprawl in our country is produced by those who are fleeing from sprawl. Do you want to live there, or do you want to go live in a beautiful area out in the country? So this is what the country looked like in 1940. This is a housing density map, and you can see that the lighter to warm colors are on a gradient from lower to high density. I've got our study area here circled in blue. So that's 20 years of change. That's what it looked like in 1960. That's 1980, 2000, okay, and that's what's projected for the year 2030. And what's really interesting about this is that the rate of housing growth has outpaced the rate of population growth substantially. And it's especially the case if you look on the chart on the bottom for lower density non-metropolitan areas. So across the country, there's been a massive increase in low density development, even faster than population. And so for our study area here, I calculated by decade from 1940 to 2010, the area of low density housing development and the area of high density housing development, and I plotted it out. You can see that the Central Coast area of California has followed the national trends and that low-density development has increased substantially, whereas high-density development increased also, but it has started to taper off a little bit. But low-density development seems to be on a continuing upward path. Okay, so, well, that's interesting, but how does this relate to wildfire? And this has been a question of ongoing research with me and my colleagues for the last decade or so. And we're asking the question, why do some homes burn in wildfires and others don't? And there's many reasons, and we'll be talking about them today. But today I'm focusing largely on land use patterns. And I'm going to show some findings that we've done looking at houses that were destroyed in the past and asking why. And then I'm going to show you some projections of a project that I'm working on right now into the future. And I have some co-authors here in the audience, David Ackerley, John Keeley, and Aaron Conlisk are all here. So before I start, we talked about the wildland-urban interface yesterday. We'll be talking about it more today, but I'd like to formally define it for those of you who don't know. It is defined as the area where houses meet or intermingle with wildland vegetation. And there are two different kinds. There's interface, where it's a higher density development where the houses go right up against wildland development. And there's intermix, which is a lower density intermix between the houses and the wildland vegetation. And it matters because the WUI, as we call it, is used as a basis for policy and management decisions. So this is a map of the WUI in California. The yellow striped areas are the interface. The orange areas are the intermix. And it's a basis for policy and management largely because it's believed that this is where most fires occur and where most fire losses occur. And so I put in the most recent 30 years of fire perimeters over top, and certainly looks like that's where a lot of the fires are happening. But we asked the question, is it really so? And to do that, we have to look at actually two different things. So is the WUI where most fires happen? Well, do certain development patterns and location influence patterns of wildfire? And in turn, does wildfire affect developments at certain patterns or locations more than others? And the other important question is, okay, so if it does, are the findings generalizable? Because as we talked about yesterday, different areas have different fire regimes that are formed based on geographical variability. So the climate, vegetation, topography of a region results in having a different fire regime. Okay, so for the first part, does housing affect wildfire patterns? Well, we've talked about already, humans in California cause more than 95% of the fire, particularly along the coast. So it makes sense that most fires start near where there's development. And this is the Santa Monica Mountains. The red points are ignition locations, and you can see they happen largely around roads and developed areas. But does that mean that more people, therefore, always means more fire on the landscape because humans cause all the fires? And some other research shows that up to a point, yes, that's true. But actually, when you get to a really high level of human presence, the relationship starts to go downward so that you have most of the fires at this sort of low to intermediate density of human presence. And we found this for California, as well as other Mediterranean regions around the world. And some other researchers have started to identify this similar relationship in other studies. So why? Well, we think it's because if you look at housing density that's going along here, if you have really low housing density, you don't have a lot of people to cause fires. And this, of course, is in a region where most of the fires are caused by humans. If you have really high housing density, you have a lot of people to start fires, but you don't have as much fuel because you have a lot of development. You also probably have faster access to suppression resources. So this is why we think that it's somewhere in the middle where there's enough people to start fires and there's enough fuel and continuous fuel to spread fires where fires are most frequent. Okay, so it does appear that development patterns and location may influence wildfire patterns, but then how does wildfire impact depending on the location or pattern of your house? And the first thing I'd like to mention, this is the Santa Monica Mountains. It's a classic example of a place where locations, some areas are more fire prone than others. This has a Santa Ana wind corridor, Malibu Canyon, and within the same period of time, you can have 12 fires happening in this area while there are 0 to 1 fires happening in another area. So some locations are just more fire prone than others, and you can see this is looking at destroyed homes in red versus undestroyed homes in blue since the year 2000, and most of the destroyed structures happen in this same area where most of the fires are happening. It's pretty, logical. Okay, well, what about the pattern? We've done studies in 2 study areas in Southern California. This is a map of San Diego County. Again, red areas are houses that have been destroyed, blue are houses unburned. And we found that in both regions, the arrangement and location of housing was the most significant factor to influence whether or not a home was destroyed in a fire. And the patterns are low density, small isolated clusters of development, and being close to the edge or the perimeter of a development. And we compared housing density and location to a whole range of other factors that also influence whether a structure is likely to be destroyed. And the pattern came out as most important by far than anything else. But there's interrelationships, and this, you don't have to really understand what it's doing. I put it here just simply to illustrate. We also looked at the home's defensible space. We calculated the distance, the amount, trees overhanging structure, and we looked at building construction materials. We looked at slope and a whole range of other factors, vegetation. And the way it turned out is that at the top, the landscape factor of where your home is located or the pattern is the thing that determines more than anything else whether the home is likely to be destroyed. But after that, other factors come into play. So for example, if you have really high density housing, then the next factor that's most important is the age of construction of your home. On the flip side, if you're in really low density housing, then defensible space comes into play. And I know that we're going to be talking about these kinds of things later today, but I would like to also mention we did some empirical work looking at the effective distance of defensible space and how likely it is to protect your home during a wildfire. And we found that there is significant protective benefit, but it only goes out to about 100 feet. And anything more than that does not provide significant additional protection and could actually increase the risk depending on what you do. So if you clear vegetation that has a higher fuel moisture content in favor of grasses that aren't then irrigated, you then create a highly ignitable landscape. Okay, now the next question is, okay, that's Southern California, but are these patterns generalizable? And my colleagues from the University of Wisconsin and I have done studies where we looked at, for example, smaller neighborhoods in Colorado. We looked at regions across the entire United States and found that consistently the arrangement and location of homes were the most significant factors affecting whether or not a structure was going to be destroyed in a fire. All the time it was more important than vegetation variables, but topography was also very important. So, the elevation or slope, the heterogeneity of the terrain in your region was important. But there was regional variation, particularly in how the pattern affects structure loss and other variables that combine to influence structure loss. But in general, there is a pattern in that low housing density and small isolated clusters of development were the riskiest. But once a fire hits a cluster of development, and if it has really high density, the relationship can reverse so that high density then becomes a risk factor. And of course, this is what happened in the Tubbs fire. You know, it was a large fire and there were many homes that were destroyed, but when it hit Coffey Park, there were 1,000 structures destroyed in a very small area. And a colleague of mine, her name didn't show up. Oh, yes, it did. Anu Kramer at University of Wisconsin has done some interesting work looking at the Tubbs fire. And she compared all California wildfires as well as the 10 most destructive California fires and looked at where they occurred. And she compared that to the Tubbs. And so historically, the percent of total destruction of homes has most often happened in interface and intermixed WUI or in rural areas. And the Tubbs fire was relatively uncommon, in which it also occurred, there was also a lot of wildland urban interface there, but it had a high proportion of non-WUI urban areas that burned. I'm also doing current work with David and Aaron and others, where we're looking at 3 different study areas in California, and we are looking at destroyed structures since the year 2000 until now, comparing that with other structures, you know, all the structures across the landscape, and calculated what is the mean housing density in destroyed structures, where are the most structures destroyed, and what is the mean housing density overall. And consistently, we find that it's in these low density areas. I have here, this is the North Coast area, the wine country area, before and after the 2017 fires. So the housing density, mean housing density of destroyed structures increased, but it's still substantially lower than overall housing density. And you can also look at this as a distribution. So this is going from low to high housing density. Here's the percentage of destroyed structures. Here's the percentage of all structures, and you kind of see this flip pattern in which destroyed structures happen along the lower density areas, and generally most structures happen in higher density areas. Okay, so summarizing the historical patterns, is the WUI where most fire losses and fires occur. And from the research we've done so far, it appears that yes, development pattern and location do influence the pattern and frequency of wildfires, which in turn affect structure losses at certain patterns and locations. Fire frequency tends to be highest at intermediate housing density, and housing pattern and location consistently are the most important factors explaining whether or not a home is going to be destroyed by a fire. There are regional differences, however, so it's really important to not have a one-size-fits-all strategy, to look at each certain region to figure out exactly what is the pattern and what are the other variables that present the highest fire risk. But consistently, across the US and otherwise, most of the time it's low housing density in small isolated clusters of development and near the edge of a structure. But once a structure is exposed to wildfire, high housing density can have a flip effect and lead to building fire spread. And that's where building construction materials become really important, as well as other home interactions. And of course, I just need to re-emphasize that this is part of a larger picture. There's a lot of reasons why structures are likely to burn. And housing pattern and reflection, what they're really showing is just the likelihood that a house is going to be exposed to fire in the first place. Because if you're never going to be exposed to a fire, of course you don't have a chance that it's going to burn down. But most of the destructive fires, like we just experienced and like we talked about yesterday, happen under severe wind and weather conditions. And some conditions may be changing into the future, like climate change, or there may be increased droughts, like what John talked about with long-term drought and potential dieback of vegetation. So now I'm going to go back to the future. Oh, that didn't come out right. This is the modeling study that we are working on right now, where we used historical data on structure loss and wildfire to create probability of large fires that feeds into a probability of structure loss. So it's a combined modeling approach. And yes, this is a black box. I'm not going to tell you exactly what the methods were, but you're welcome to ask me. And for these, we subjected them both to two different scenarios of future housing growth, One concentrated more on low density, one concentrated more on high density, and we also looked at 2 different climate change scenarios. And we did this for the 3 regions in California that I showed you earlier, but I'm only going to present results from the one in our study area, the North County wine country area. So first of all, looking at the variable importance of our models for large fires, and we did all fires as well, but we're looking mostly here at large fires. We're largely influenced by topography, climate, and fuel, but the probability of structure loss was most influenced by the likelihood of fire and the housing pattern of the structures. And this is what the pattern looked like. Small clusters of housing close to the edge, low housing density. Okay, what these charts are showing you is you have 2 climate change scenarios for large fires. You go from left to right by decade, and you look at the probability of wildfire under green, the low density rural growth scenario, and red, the high density urban growth scenario. This black line is showing you the probability as it is today, actually as it was in 2009, that was our baseline year. So what you see is that under most cases, if you are looking at fire in the future, it's projecting up to 2050, it's likely to increase. There's a bigger effect of climate scenario on large fire probability. Oops, I just flipped to the next thing. So I'll just flip to the next thing. The development scenario had less of an effect on wildfire, but if you come to the probability of structure loss compared to baseline conditions, the development scenario becomes extremely important to the fact that if you project into the future with rural development, you have an increased likelihood of structure loss, whereas if you do an urban development, you have a lower probability of structure loss. And there is some variation based on climate. Okay, you can look at a map. My time is running out, so I'm going to go fast. The only thing to look at here is that this is the probability of structure loss in the, this is 2 climate scenarios. In the rural scenario, but if you were to concentrate development in the future in higher density urban, you decrease the extent and probability of structure loss. Of course, these are models, they're not predictions, and thank you to Leroy for explaining that to us earlier. And you can also subtract that. But let's go to what it means. So I think future risk, the take-home messages from this is future risk to structures is going to depend on how change happens in the future and how much change happens in the future. Large fires may be more sensitive to climatic or topographic conditions, whereas structure loss is more sensitive to development. Although we did a thing of all fires of all sizes, and they were sensitive to development patterns. So preventing rural sprawl may potentially prevent more structure loss in the future. And what will the future look like? Well, remember what Confucius said. And I'm running out of time, but this is also by my colleague Anu, who this is basically just showing that for some reason, housing growth happens disproportionately higher in areas where fires have occurred, particularly in the Tubbs fire, if you compare that to housing growth in general across the state. So there's something about fire locations that's really appealing for people to put their houses. And there's probably going to be more growth. And there's going to be more growth in the Bay Area. And so what's next? We've obviously seen a trend of increasing losses, but armed with an understanding of the past, we have the tools to create the future. And that's it. Oh, no, that's it.
Stay here.
Oh.
Okay, we have time for one direct question to Alex if someone wants to ask a direct question to her. But we're going to begin our 30-minute discussion section. So I would ask Leroy and Dave and Alex to please grab a seat here. And they're going to be available to talk to you for the next 30 minutes. So this is a direct question for Alex. Great.
Yes. I noticed on one of your slides you showed the wind speeds coming in during the Tubbs fire, and it made me think about the fact that there's an awful lot more instrumentation and sensors out there nowadays than were there in a lot of the earlier fires that you reconstructed. Are you taking that into account in these models of risk and as you project forward?
We are not, in our structure projections and in our structure models and mapping, we are not accounting for variation in wind simply because it's too difficult to actually quantify it, or it has been. Maybe in the future we'll actually be able to get that. But in general, most of the time houses are destroyed by fire. It's happening when wind conditions are pretty extreme. So there's not a whole lot of variability in structure loss based on wind conditions, because it's usually a high wind condition.